And welcome to the Daily Space Weather Show, coming at you from the Smash News Network, least busted name in news, and pardon my Muppet-like appearance. That's the past 24 hours from SDO. 2 new active regions rising here. They are sunspots that have made it all the way around the sun for a full Carrington rotation, which, by the way, takes about 25 days at the equator. Here are some closer views for you. You're looking at 304 angstroms plus 171 angstroms, 60-minute running difference. Great at showing magnetic filamentary lower coronal loops, as well as the active regions. Some well-defined coronal holes also showing up there. We'll get to those a little bit later in the video as we bring you a heapin' helpin' of information about what's going on from the weather up there at the closest star all the way down to the lower 48. Here's the northern polar region. We do have a solar flare watch still in effect in the southwestern limb. This area down here is certainly the most likely spot to see a large solar flare at the moment, as we start to lose sight of a sunspot's magnetic field shear and so forth. We start to get a higher and higher level of likelihood for large solar flares. Proximity to the limb itself is a solar flare contributing factor. Does it have to do with just the orientation of the observer? It could be, folks. It could be. We'll have to save that for a different video. Plausible theories as to why solar flares are more likely at the limbs than in the center of the solar disk. A phenomenon known to some as the Earth-facing quiet. Anyway, here are sunspots, and we've seen a significant decline in sunspots since yesterday. We might see a fairly leveling off of the sunspots in the coming 24 hours because we do have multiple active regions rising in the east. Here's our magnetic field diagram, the SDO colorized magnetogram. Very nice. And let's get to volcanoes, as we've got a fantastic image here of Merapi, a classic volcanic image there. That one is from just the past couple of days, I'd imagine. I think it says the date somewhere. Anyway, these are the other erupting issues. Suwanosejima, unknown volcanic ash plume there. Don't pole vault the caldera, folks. If you're going on a volcanic vacation, leave the vault pole at home. Semeru, also Dacono, Popocatépetl, exploding. 21,000-foot ash plume there. Santiaguido, Fuego, Revenador, and Sabancaya to round out the list. Next, looking at earthquakes for the past 24 hours. And that's not earthquakes. That's solar activity. There we go. There are the past 90 days of earthquakes, and we have some quakes that could be foreshocks here, folks, so be prepared for this one. We had a 4.2 magnitude quake at San Bernardino. So if that's a foreshock, it could be the predecessor to a larger event there. And I don't usually call out quakes below a 5 magnitude, but a 4.2 at San Bernardino is serious. So as far as 5 and greater magnitude quakes, not too many in the past 24 hours. There was a 5.6 at Indonesia at 12:24, a 5.0 at Turkey at 13:04, and a 5.4 at Djibouti. What's wrong with Djibouti? It's got too much junk in the trunk. That 5.4 was at 1700 Universal Time this evening. Papua New Guinea had a 5.1. Chile had a 5.0. Those quakes only about a half an hour apart. China had a 5.3 as the aftershocks continue near the Kyrgyzstan border. And that is where the quake coverage ends. And the space coverage comes back. So here we're going to show, actually, let me switch back to the mini-me size, because what's up with that? So we've got a lot of interference there on the SDO. I suspect there is some sort of activity going on in space there. It looks like a cosmic ray strike or something to that effect. It could be radiation from those new rising sunspots, but you see a series of lines across the imagery there. That looks like interference directly on the aperture to me. You'll be able to see it in this view as well. That is 171 angstroms along with 211 angstroms, 60-minute running difference, to show the extended corona. And yeah, so that's interesting. Of course, in space, there's a lot more exposure to things like radiation and particles. Here are these new active regions rising. I suspect they're both probably sunspots. I think we only have one small umbra having risen at this point, so this is a bit of a prelude to the actual rising of those sunspots. This video taking place a little bit before they're in proper view, but there you can see the rising aspects of them. And before we get to things like coronal holes, let's take a look at some space weather stats, like the 10.7 centimeter radial flux, which is now at 160, I think it is. 160 is the radial flux, something like that. There's the 1 year graph. That's showing 180. I think that's not updated yet. 161 is the radial flux, according to Space Weather Enthusiast's dashboard. And like we've been saying for days, more geomagnetic storm activity likely. We've been seeing no impact, so it's kind of weird. I mean, we're not usually wrong, especially NOAA and me, and I don't know what NASA's been saying. I don't know what Tamitha Scove's been saying, but let us know in the comments what other people have been forecasting. We've got geomagnetic storms likely tonight, geomagnetic unrest, Friday night and Saturday night. So it could be a weekend of awesome auroral views. So yeah, look, you can only forecast based on what you see, and so we stand by our forecast. This is just how it works. Sometimes you think it's a hit, but it's a miss. So hey, at least everybody's on the same page. Next Earth's magnetic moment from space for the past 4 hours, and that's what's going on. It's still geomagnetically calm, so no major geomagnetic storm conditions. And let's zoom in a little bit closer for the ground magnetic perturbations map and get my Muppet-looking self off the screen. So there are the past 4 hours. Pardon my Muppetness. That's Earth's magnetic moment from the ground. And yes, I use the infrared sauna. See the Amazon shop for the bulbs that we use in the infrared sauna. KP index is currently at KP 1.67. That's Amazon.com/shop/smashomash. So lots of great items in there. It's geomagnetically calm. Let's check the solar wind. There's ACE. So a big uptick in solar wind density at the ACE, now up to about 6 protons per cubic centimeter. Make it 7. Solar wind speed here, kind of low, 381 kilometers per second. That's nominal. Same thing with Discover. About 5.5 protons per cubic centimeter for the solar wind density. Solar wind velocity just under 400 kilometers a second. Unremarkable. GOES magnetometers are pretty unremarkable as well. It's been boring for space weather, frankly. We've been expecting some space weather that we just ain't getting. So that's kind of weird. I mean, again, that doesn't happen very often. We're usually quite accurate with it, but sometimes, I don't know. Maybe UFOs are siphoning off the plasma, folks. I'm sure we can figure out a way to be spooked of the lack of space weather, space weather, whatever it is. I'm sure we can find a way to be spooked of it. So let's get our heads together in the comments and figure out a way to be frightened. That's what YouTube's for, right? Anyway, there are the past 3 days of GOES magnetometers. And next on to the top view ecliptic plane field plot, one of my favorites. Earth is in a South Pole magnetic sector. Nothing to really comment on there. It's kind of boring for space weather there as well. Here's our line of sight field plot, and right in the middle of a South Pole sector is going to show a big fanned out B field as South Pole magnetism is mainly facing Earth. Here's our coronal hole line of sight plot, and the main North Pole magnetism is down there at the South Heliographic Pole, but we do have some North Pole coronal holes here rotating in. So Sector boundary crossing looks like it's maybe 2 to 3 days out. And before we get to sunspots, let's take a look at coronal holes. There we go. That's the past 24 hours once again. And two well-defined coronal holes here rotating in. They're both of south pole orientation. So that's what's up. Next, sunspots. And sunspot number has dipped below 100. So if you want to be spooked about not enough sunspots, maybe below 100 is a good spot to be spooked. And let me just bring up a little thing here just to give you an idea of what this really means. So what I mean is you can see that the solar cycle progression here does feature wildly varied. Now these are smooth numbers actually, so this doesn't show you the full variation, but the sunspot number varies by a lot. And of course, back in solar cycle 24, the sunspot number was dipping below 50 quite often in the smooth sunspot number. And now you can see it's mainly staying above 100. So a much stronger solar cycle here, and we still aren't at solar maximum. We're not expecting that until sometime late in the year in 2024, like September or October. So that's what it ultimately means. And let's take a look at the synoptic map next. We have a high likelihood of X-class solar flares. And again, like I said earlier, my favorite spot is down here in the southwest. So that's the scenario for flare likelihood. Here's our probability map and solar flare scoreboard. Sunspot 3555 and 3561 are the most likely places to see a large flare. Let's take a look at sunspots here next. There's the past 24 hours. Again, we'll see a decline in sunspot number likely tomorrow, depending on how many rise in the east. So we're likely to see some rise in the east and some set in the west. Flare likelihood is most likely in the southwestern limb. There still is some likelihood of large flares in those other sunspot groups, though. So moving on to energetic particles, before we get to our cosmic ray report, there's the solar proton flux, or the GOES proton flux, measuring relativistic protons that have made it to Earth's magnetosphere. And let's get to cosmic ray flux. So we haven't done a cosmic ray report here for a while, so let's go over cosmic ray flux briefly. And we're seeing the lowest levels in the past 30 days here. So a 30-day low happening right as we make the video at Apatity. We'll also show Barentsburg and a downtick over the past 30 days at Barentsburg as well. Let's go down south to Greece. There's the Athens neutron monitor. And Athens actually, interestingly enough, showing an uptick in the past 30 days at Athens. So that's a bit unexpected. You can expect all cosmic ray monitors to continue to show a downtick for the past about 15 months. At least 15 months, probably more like 20, but I'll say 15. There's the Athens neutron monitor, a small uptick there. Next, we'll go to the Mexico neutron monitor. And a slight downtick at Mexico City for the past 30 days. We'll also look at Oulu and Antarctica. So there's Oulu, Finland. Downtick over the past 30 days at Oulu. DOMC Antarctica, downtick for the past 30. And DOMB Antarctica, a downtick for the past 30. So Athens is the outlier there. And let's move on to solar flares. Yes, solar flares. They can't melt the face of a Muppet. The X-rays never make it to the surface of the planet. So I guess if a Muppet's in space, the X-rays could ionize that Muppet. Cause some radiation exposure. Anyway, flaring has been minor for the past 24 hours. No M-class events on January 25th. Next, moving to the flare wavelengths that we like to show. There's 94 angstroms 60-minute running difference along with 131 angstroms. Yes, the SDO. And you can see in those wavelengths those lines appearing there. So that looks like legit interference on the aperture. I don't think that's some kind of a data loss. And here is the T-mass. Our T-mass, today's most active sunspot. 3555 and 3561 was it? There's the extreme close-up of that. And like yesterday, we do have a flare watch on the eastern limb as well, but a more significant flare watch in the western limb. That's the southwest. And before we get to CMEs, let's take a look at a star chart. So let's see what's going on overhead. This star chart is for Lehigh Valley, Pennsylvania from skyandtelescope.org. That's what's going on now. We've got a full moon coming. So Full moon tonight. Happy full moon, folks. Here comes your solar system forecast. This is where heavenly bodies lie today. That's where they'll be in 1 week on February 1st. Next, our astronomy photo of the day, and it's featuring ice crystals being illuminated by streetlights and creating pillar-like ice towers. Towers of icy crystals in the sky over Finland. No, wait. Yeah, over Finland. So there you go. Some towering ice crystals illuminated by streetlights. Okay, I guess that counts. Sounds like meteorology to me, but you get a pass. Next, coronal mass ejections. And do we have additional events headed toward Earth? Fingers crossed. Fingers crossed some actually get to Earth. And things are looking pretty chill there. I'm not convinced there are any new CMEs headed our way at this point. So let's skip that. We'll go to the close-up views. There we go. I'm going to let the C3 catch up. There we are. And things are looking pretty calm from the coronal mass ejection front. So only some minor events and unlikely to be earthly directed. And if they are, they will barely produce a blip, especially considering the recent activity. Producing bupkis, zilch, nada, nothing. Here are our custom coronagraphs. Conveniently synced with the SDO. Yeah, those are not earthly directed CMEs. Here we've dropped the C3 and added the 193 angstroms wavelength. And is that a comet up there in the upper left? I don't know. If so, it looks like it's breaking up fast. Let's zoom in one step closer before we get to filaments, and we've made the full circle. Coming right back to where we started the video out. So, next going to filaments. And here we go. There's Cerdo Tololo. We do have some filaments. These are named after our viewers, by the way. So I think this one's called the Renee Gable, and this one's called the Kimberly Nichols. Yes. So shout out to our viewers. If you want to name filaments after living people, do it over on Twitter, x.com/smashomash. Follow the hashtag #NameThatFilament and name filaments after your friends, your foes, or even yourself. Follow America's favorite pastime. Name that plasma filament. Anyway, before we get to bonus features, there are the past few hours from the closest star. There, that's that thing that they have, that place up in the space that goes 16. The thing in the space place that goes 16. And don't make me punch your face by saying that the space place is fake. You know, we get those comments, folks. Every once in a while, we get a comment where somebody goes, "Dude, space is fake. You're a NASA shill. You work for the CIA. You're a CIA appeaser. Why I oughta go. Don't make me stand up. You probably believe in the moon landing." Anyway, that's a way to kick off the bonus features. Again, pardon my Muppet-like appearance. All right, moving right along. My skin is softer than the Muppets. Yes. Yes. Bonus features start out with satellite charging hazards. We ain't got none. Goes electron flux. It's cratered. 1 year electron flux graph. There it is. It's pretty uninteresting, but we have an electron shortage. The longest one of the whole year. Oh no, if you're spooked of electron shortages, it's time to get in your bunker, folks. Get in your bunker. Oh no, there's not enough electrons. Dear God. Next, the forecast model. There you go. There's the forecast model. It's expecting an uptick followed by a small downtick. I don't know. It's pretty boring. Next, getting to the ionosphere. That's what's next. Here's the F layer. Son of an F and F layer. Here it is in vibrational frequency. What is... Oh my dear God. Dear God, the ionosphere is pretty boring like the rest of space weather today. Pardon the boring space weather. And if a lack of space weather gets you scared, then today is a great day to be frightened of a lack of space weather. Oh no, there's not enough space weather, folks. I gotta climb down into the bunker. Oh no. So, yeah, we'll also show the wham. Wake me up before we show you the wham, because otherwise you might not be using your ham radio properly because you didn't pay attention to the right frames. Your GPS will, you might be able to use your GPS if you pay attention to the left frames. I don't know. Like it could prevent your relying on the GPS and having navigational errors and things. Or it could prevent your radio signal from going into space instead of to your recipient. By the way, make sure you subscribe to Eugene the Philosopher. Otherwise, you won't realize that it's too late. It's already too late, folks. It's too late. Dear God, it's too late for you to submit the question for this week's Ask a Particle Physicist segment. But go subscribe to Eugene's channel anyway. There are his most popular videos. Yes. Eugene the Philosopher, the most significant contributor to our channel. Ask a particle physicist a quegment. Yes, ask them a quegment. Now, I'm not sure what a quegment is, but perhaps that should be a new word. Today's made-up word is quegment, a question segment, or maybe a questionable segment. Are you a questionable viewer? Well, then leave us a questionable comment. Are you a coward? Do you think we're scared of your comments? Dear God, just leave a comment already. All right. Anyway, ask a particle physicist a quegment for the a question for the quegment, a quegment question for the segment. That's what it is. A question for the segment. You can do so at the forum, smashomash.com/forum. It's in the general science forum right there. You just click on the Ask a Particle Physicist segment, and then you're there. And then you type in a thing, and then you got to log in and things. But that is how to contribute to the quegment. Anyway, moving right along to our latest. There's the continuum. There's the magnetogram. And again, I only saw one small umbra over here. So far, not very exciting. One little tiny umbra there rising so far, but there might be a lot of fireworks behind that. So, and as far as that set goes, zilch. So, expecting sunspot number to drop if trends continue as they currently are. Next, let's get the weather, and we're looking at sea surface temperature and ocean currents. So this is our meteorology segment. We throw this in as a value-added feature. Because I started doing space weather partially because of meteorology, I realized this was too easy. And so I needed a greater challenge. Forecasting weather is far too easy. Space weather, slightly more interesting. So, those are sea surface temperatures and ocean currents, by the way. We were going to show sea surface temperature anomaly, but it looks too crazy. So let's just go with sea surface temperature. So that's what's going on. Ocean currents and sea surface temperature. We'll show the whole world's oceans. So the animation is current, and the coloration is ocean temperature. So there's the Atlantic. Here's the Southern Ocean. The Indian Ocean. Let's don't forget the Pacific. And of course, the Arctic is not going to have very much current, as it's mostly frozen. Continuing on to clouds and fog. And we hope that wasn't too controversial saying that the Arctic is frozen. It is wintertime, by the way. Anyway, there are clouds and fog over the Americas. And if you're offended by that, I don't know, maybe use the visible satellite, which is going to be half dark. Maybe you'll be only half offended. We'll also show Bermuda. Yeah, there's a massive Atlantic low in the western Atlantic there over Bermuda. You can see that counterclockwise rotation. It's kind of weak, but it's also really, really huge. So that is a massive low, and you can see that clockwise rotation and a bunch of gloomy clouds there right around Bermuda. And the Bermuda Triangle, by the way, is like something like this. Or something. Something like, I don't know. Bermuda's at the tip of the triangle. I don't know. Who cares? But that's why we've zoomed in on Bermuda. And if you're wondering if Bermuda gets good surf, the answer is no. The surf sucks at Bermuda unless there is a storm. So don't go there as a surf spot unless you know the weather. It's part of the reason why we show it. I'm a wave chaser. What about you? So anyway, that's precipitation type. And most of the U.S. is getting rain, but as far as precipitation, some, namely the Rockies, is also getting snow. Also a bit in Oregon and in Washington. Here's our weather.gov map, weather.gov. Get your weather warnings. Don't rely on me for them. Go to weather.gov because those are far too many counties expected to be flooded for me to cover. Here are our forecasts, starting with the Tropical Tidbits GFS, pressure and precipitation. Watch out for those pink spots. That's freezing rain. Use your brain and don't find yourself in automotive pain. Next, I'll fumble around with a bunch of keys and press keys erroneously, and I hope you'll enjoy that. That'll be fun for us all. Next, we'll show total accumulated precipitation in inches. And like we said, Narlands is going to get some gnarly rain. Some gnarly rain in Narlands. Also, the Pacific Northwest is a very moist location. Next, accumulated positive snow depth change in inches. The same model, the GFS 72-hour model. Snow depicted here. Temperature anomaly depicted here in degrees Celsius, 72-hour GFS model. The warm is staying mostly in the east, finally dissipating. Keep in mind it is the coldest time of the year, typically in most years. Next, our GFS jet stream forecast depicting the 250 millibar winds. Next, lightning. And we had some heavy lightning there going from Texas across the Gulf Coast. Or I could say along the Gulf Coast, depending on what kind of prepositions I want to use. Yeah, along. It's a preposition, all right? And if you don't like it, you could go to hell, okay? You could go to hell. Because to hell is also a preposition. That would be a direct object. The subject being you, the verb being go, and the direct object being to hell. Anyway, there's the current lightning map from lightningmaps.org. Lightningmaps.org, folks. We'll close out the space weather video with U.S. Doppler radar. That's what's going on in the lower 48. Quite a bit of rain there. St. Louis, it's almost cleared up. There is clouds and fog, and there are the data for water vapor. We do have a little pocket of dry, massive air there bouncing around in between the moisture. Here's your recap. That dry, massive air there pushing its way up towards St. Louis, where it's going to clear up soon. You're going to have a clear view of the full moon tonight, St. Louis. Next, clouds and fog. Wait, this is the recap. I don't got to say next. There's a water vapor map, and I'm out of here. I'm headed back to the bunker because I am spooked of moisture, dryness, not enough solar activity, too much solar activity, filaments, sunspots, no sunspots, coronal holes, no coronal holes. Even each one of those stars back there, I am spooked of each one. So I'm going to go hide from those in my bunker. In the meantime, may that solar wind be at your back. As I go back to the bunker again, lots of dumb stuff on YouTube encourage me to climb in.